Selective Breeding of Honeybees for Resistance to Varroa Mites by Mary Bess Mercer. Apis mellifera, or the Western European honeybee, is the most common honey-producing species worldwide. This bee adds approximately $18 billion of value to the United States agriculture industry annually, helping to pollinate crops and producing around 25 kilograms of honey per hive per year. What are Varroa mites? Varroa mites, or Varroa destructor, are the most common parasites in Western European honeybees. These mites originated in Asia and were accidentally introduced to susceptible European colonies in the 1950s. Varroa mites feed off of the hemolymph of honeybees and spread deadly pathogens and diseases such as deformed wing virus, or DWV, which is an RNA disease that causes wings to twist and shrivel in adult bees, affecting their ability to fly and leading to colony losses. Sticky screens, or screen boards, trap mites at the bottom of the hive, making them unable to feed and reproduce. This is seen in this first image by honeybeesweet.com. Miticides and pesticides kill the mites, but can lead to other negative effects for hive members. Sugar shaking is when keepers shake powdered sugar onto bees, and it causes the mites to lose their grip on the adult honeybees, leading them to fall to the bottom of the hive, working similarly to the sticky boards. Selective breeding, or genetic resistance, is the main focus of this presentation today. It is the process of breeding naturally resistant bees to create more resistant hives. The main question for this presentation is, can selective breeding lead to parasitic resistance in Apis mellifera? In order to select bees for this breeding process, there are three main points that are looked at: grooming behavior, hygienic behavior, and hive attractiveness to Varroa mites. Grooming behavior is the main mechanism for Varroa mite resistance in Western European honeybees. Grooming involves one bee using its mandibles to clean a fellow hive member. While performing this act, mites can be injured or killed by the bee's mandibles and fall to the bottom screen of the hive. When studies of mite resistance were performed in Mexico, hives that groomed more often would have much lower mite populations than ones that did not groom or groomed less. Hygienic behavior is similar to grooming behavior. This involves detecting and removing diseased or infective brood within capped cells. After the removal of the parasite, hive members will attack the exposed mite and remove it from the population. Hive attractiveness is measured in the amount of brood infested. Attractiveness is an important factor when searching for resistant colonies. The more attractive a hive, the less resistant to mites. The chemistry of larva food and larvae themselves have a great effect on attractiveness. Mites prefer broods with higher zinc and copper concentrations because these metals are important for insect growth and fertility. In this image here, you can see two bees grooming each other with their mandibles. The effectiveness of selective breeding processes. During an experiment, closed selective breeding of Russian Apis mellifera queens resulted in a largely negative trend for mite population growth within the hive. Each line that was bred within this population was tested and propagated to ensure maximum Varroa resistance. Each year of this project, the Russian group had more negative z-score than the last, which is the desired result of this experiment. Non-selective Italian Apis mellifera groups and non-selective Russian groups within the same aviary that did not have closed breeding practices showed a more positive correlation for mite breeding in comparison to the selective group. This is seen in Figure 1. Instantaneous mite population growths within the non-selective populations were also noticeably higher than the selective groups. The selective Russian group had a decrease of mite population growth annually, while the Italian group had varying growth rates, all being much more significant than the experimental group. The selective breeding of the Russian group showed no negative effects on honey production or overall gentleness of the populations, which shows promise for further production of this line of bees into the agricultural industry as a whole. Apis mellifera is the leading producer of honey worldwide, and Varroa mites are the main source of colony loss within this species. These experiments help us understand the impact of genetics in parasite resistance. Selective breeding for genetic resistance of these mites without harming honey production or increasing aggressiveness of the species could help to mitigate overall population loss. In conclusion, Varroa destructor is a major effector of hive stability in the United States and is the leading cause of hive collapse. Research for resistance could lead to the eradication or significant decline of Varroa populations in the U.S. New ways of forming resistance to Varroa mites could assist in bee conservation and create more stability to vanishing bee populations. Thank you.